Okay, so we're going to be talking about the definite integral, of course, is area under the curve. Now, we've been doing rectangular approximation, and so what I'm going to do is I'm going to use those questions that we've already worked, that we've approximated the area for, to now do exact area. Okay? So, this is the equation that we're going to be using. This is the definite integral. Okay? This is saying if I'm looking from the area where it starts at A, so the beginning, this is where it ends, that's the area I'm looking for. Under that function, I can use the antiderivative. So capital F is the antiderivative of F. Okay? So I'm going to use that equation. So we used MRAM to find the area under the curve from 0 to 6 using 12 intervals. Now I'm going to use the definite integral. Okay? So again, I'm going to be using this equation from A to B. My function f of x dx equals the antiderivative of b minus the antiderivative at a. So I know what f of x is. So now I got to find the antiderivative. So if f of x is 3x squared plus 2, the antiderivative is going to be x squared plus 2x plus c. A is where my area starts at 0. B is where it ends at 6. So this is the stuff that I need to know. Okay? So, here we go. Plug in everything here. So this means I've got the integral from 0 to 6 of 3x squared plus 2 dx. Okay? That's going to be equal, and this is where I plug the antiderivative in. So I get, sorry, this is supposed to be cubed, x cubed plus 2x from 0 to 6. Okay, so this is the integral evaluation bar. Now we plug in, this of course is my antiderivative, so we're going to plug in b first, which is 6. So it's going to be 6 cubed plus 2 times 6 minus this part, f at a, or the antiderivative of a, which is going to be 0 cubed plus 2 times 0. Okay? And again, this is the antiderivative at b minus the antiderivative when I plug in a. So this is going to be 216 plus 12 minus 0, which is 228. And that is the answer. Okay? Now, the second one, same thing. Okay, we're going to use the same equation. So, again, I know what f of x is. F of x is 2x cubed plus 2. So I need to find the antiderivative first. Okay? So 2x, when you find the antiderivative, you add 1 to the power, which is 4, divide by the new power, which is 4, plus 2x plus c. Okay, and we'll simplify that to 1/2 x to the 4th plus 2x plus c. A is -1 and b is 2. So when I plug it into my definite integral, it's going to be from -1 to 2 for 2x cubed plus 2 dx. So now, that's, take the antiderivative, so we get 1/2 x to the 4th plus 2x. Notice I'm not using the c. We don't use the plus c when we do this. Okay? And again, I'm using this to help me create this. So I'm first going to take my antiderivative and plug in 2 minus the same one when I plug in -1. Okay? And here you're going to get 8 plus 4 minus, this is 1/2 minus 2, So this is 12 minus negative 3 halves, which is 12 plus 3 halves, or 27 over 2, which is 13.5. And that's the area, which when we approximated it was pretty close. But that's actual area. That is the area between -1 and 2.